All right, so we're going to be doing chapter 6.3, performing operations and compositions with functions. So remember that your operations are addition, subtraction, multiplication, and division. When we talk about operations with functions, we are going to say let f and g be any two functions a new function h can be defined by performing any of the four operations. On f and g. So meaning when we add, subtract, multiply, or divide f and g, we're going to get a new function, which we're going to call h. So let's say we are adding. Our new function, let's say h of x, would be produced by adding f of x and g of x. And our new function h of x could be made by subtracting g of x from f of x. And of course, you could switch these around and do g of x minus f of x. It's whatever you're being asked to do. But what you need to know is that once you do that, you end up with a new function. So let's try this example. F of x equals 4x to the 1/2. G of x equals negative 9x to the 1/2. So we're going to add f of x plus g of x. So let's just call our new function h of x. I need f of x is 4x plus 1/2 plus g of x is negative 9x to the 1/2. Now, just like we were talking about with our properties of exponents, notice that x to the 1/2 is the same thing. So since these are the same, I can just go ahead and add the coefficients. 4 plus a negative 9 is negative 5x to the 1/2. And that's your new h of x. We can do the same thing with subtraction. Let's call our new function h of x, f of x minus g of x. So 4x to the 1/2 minus a negative 9x to the 1/2. I just put this in parentheses so you can see we're subtracting a negative. So really we're going to end up adding here. And again, x to the 1/2 is the same as x to the 1/2. So we're going to add them, and we have 13x to the 1/2. And that's our new h of x. Now you don't always have to call it h of x. It's kind of up to you, but in general in our definition, that's what we end up calling this new function. All right, let's look at multiplication and division. Same thing, if you multiply two functions, you're going to get a new function h of x. So h of x equals f of x times g of x, maybe if I ask you to multiply, or we could also divide. F of x divided by g of x. And you always simplify as much as possible. So here, let's say f of x is 3x and g of x is x to the 1/5. If I'm first asked to multiply, I've got a new function, h of x. I'm going to multiply 3x times x to the 1/5. Now again, we have to use our properties of exponents. Notice that the bases are the same here, x and x. And x is to the first power, even though nothing is written there. So what we're going to do is add the exponents and keep the bases the same. So that 3 is going to stay as is, x, and we're adding 1 plus 1/5, which is just 3x to the 6/5. And that's your new function. Just your properties of exponents. Bases are the same, add the exponents. Next one, we're just going to divide. So again, I got a new function. I've got f of x divided by g of x. Again, use your properties of exponents. Bases are the same, so I'm going to subtract the exponents. So I've got 1 minus 1/5. So you could rewrite it as 3x to the 1 minus 1/5 if you would like. And that is 3x to the 4/5. So whatever your two functions are, you can multiply them to get a new function or divide them to get a new function. The code word for today's video is composition, because that is what we're going to do next. We say that the composition of a function f with the function g is given by, again, h of x, because we have a new function, f of g of x. What we have is g of x is the input into f of x. So instead of just substituting in a number like we're used to doing into functions, this time we're going to actually substitute in a function. The order in which you do this to simplify is you always start on the inside. And I'll show you what that means in just a second. Again, a composition is when you take a function and you input it into another function. So let's try composition with numbers first as our input. Here we're given f of x is 3x minus 8 and g of x equals 2x squared. We're going to try g of f of 5. Every time you open a parenthesis, you say of. G of f of 5. This is saying that I need to do f of 5, and then whatever that input is, input that into g. So we're starting on the inside. So first I'm going to do f of 5. Everywhere I see an x, I'm going to replace it with a 5 into my f function. So 3 times 5 minus 8. 15 minus 8 is 7. Now, if I replace f of 5, now I know that's 7. So I do g of 7. I'm going to replace x with 7. 2 times 7 squared. Order of operations, 7 squared is 49 times 2 is 98. And that is your answer. Start on the inside. I did f of 5 first. I got that input, replaced x with 7 into the g function. So let's try f of 5. This is saying that I want to do f of 5, get that answer, and then plug that into f again. When we do compositions, we're doing things 2 times. So I'm going to do f of 5 to start with. Same one as last time, we get 7. Now f of 5 is 7, so now I'm going to do f of 7. So 3 times 7 minus 8. So I've got 21 minus 8 is 13. So if you're doing composition with numbers as the input, you're going to end up with just one number as your answer. But sometimes we're going to do composition where we're not inputting a number, we're just inputting a function. So let's try a couple of those. For this first example, I'm going to say if f of x equals 4x plus 2 and g of x equals x minus 3, find the composition
Steve Heffernan, please contact extension
of f
1661.
of g of x. So we're saying that our new function h of x is f of g of x. I'm substituting in g of x into the function f of x. So I could rewrite this as f of g of x is x minus 3. So that means everywhere in f of x, I'm going to replace x with this entire function, x minus 3. So I've got 4 times x minus 3 plus 2. Distribute the 4x minus 12 plus 2 is 4x minus 10. That is your new h of x. So when I input a function into another function, when I do the composition, my new answer is another function. Let's try one more of those. Given f of x is 2x to the negative first power and g of x is 2x plus 7, let's find f of g of x. I'm going to try it with different colors. So I'm going to do f of x as my blue function and g of x as my red function. So let's say I'm going to do f of g of x. So we could rewrite this as f of 2x plus 7. So that means everywhere in f, I'm going to replace x with 2x plus 7. So I've got 2, there's an x. I'm replacing that with 2x plus 7 to the negative first power. Remember, we don't want to leave our answer with negative exponents, so to make that positive, I move that entire parenthesis to the denominator, and that's my new function. So let's call that h of x equals 2 over 2x plus 7. Let's try g of x. We're going to take g of x and substitute it into itself. So another way you could write this is g of 2x plus 7, because that's what g of x is equal to. Everywhere I see an x, I'm going to replace it with 2x plus 7. So we've got 2 times 2x plus 7 plus 7. I replace this x with this entire expression. So again, distribute the 2. 4x plus 14 plus 7. Just add your constants. So we could say h of x equals 4x plus 21. A real-world application of this problem is when we think about discounts at a store. So we're going to do a couple of these problems, but I want to show you one example. So let's say you're buying an iPod and they're having a sale at the store for $75 off all iPods. Then on top of that, you can get another 15% off if you open a credit card. So we're going to do this example using composition of functions to show you how this could be used in the real world. So we're going to walk through it step by step. Use function notation to describe the cost f of x of getting $75 off an iPod. So I'm telling you, x represents the price of an iPod. So if I'm subtracting, I'm taking off $75, my function would just be the cost of the iPod, x, minus 75, because that's my coupon, or that's the sale that the store is having. Use function notation to describe the cost g of x of getting 15% off when opening a credit card. So let's say I just got that. I didn't get the $75 off. I just got 15% off. I would represent that by I'm taking the entire price of the iPad and I'm subtracting 15% off of the cost of the iPad. So let's combine our like terms. We've got 1x minus 0.5x. So this simplifies to be 0.85x. So let's think about this. If you get 15% off of an item, you're paying for 85% of the item. That's what this is showing. Now, let's say you're getting both discounts. That's what the composition is representing. So let's say we have f of g of x. That's saying we have f of 0.85x, because that's what g equals. So in my function f, I'm going to replace x with 0.85x minus 75. What does this tell me about the cost of the iPod? This is saying that first I'm applying the function on the inside. So this is saying first I'm taking 85% off, 15% off, and then I'm taking off $75. So this is first taking 15% off, then taking $75 off. Now, if I do it the other way around, g of f of x, g of x minus 75, in my function g, I'm going to replace x with x minus 75. So I've got 0.85 times x minus 75. So I need to distribute 0.85x minus 75 times 0.85 minus 63.75. So this is saying that I'm doing the function on the inside first. So whatever my cost of my iPad is, I'm going to take $75 off. Then I'm going to take the 15% off. So I'm doing the order of the coupons in a different order. So here I would take $75 off, then take 15% off. So in a real life situation, I want you to think about which order of the discounts get you a better deal. If you really were buying an iPod, would you want them to take 85% off the full price, then take off $75? Or would you want them to take off $75 and then take 15% off? You want them to take the percent off the bigger number, then subtract $75. So it's a better deal if you take 15% off, then take 75% off, or $75 off. You could try these with actual numbers. If you made up a number, maybe an iPod costs $200, plug that into your function. It'll be cheaper if you take the 15% off than the $75. So compositions, we usually say, are used in the real world. We usually do examples where we're doing coupons. So we'll try some more of these, or maybe we're taking a percentage off, and then we're also taking a certain price off the product as well.